Greetings, my name is Mike and welcome to the video, and today let's have a look at coroutine basics on Android. Now there are a lot of crazy and wonderful concepts that float around with coroutines, like coroutine contexts and dispatches and scopes, and then there's even this magical suspend keyword. So it can be a bit much, but don't worry, I'm going to go through each of them and show how they all fit together to form the wonderful thing that is Kotlin coroutines. All of this code, by the way, that I'm working on is on my GitHub repo, and there's a link below for that, so check it out if you're interested. But let's have a look at the sample app first. I'm just going to open the coroutines demo, and it's going to be broken for now because I want to actually implement this stuff. So it's going to show a progress bar, do a service call to fetch a list of Pokemon, and then just display a few of those items on the screen. So that's all, not very exciting, but the important stuff is behind the scenes after all. So let's take a look at the code. In the activity, there's nothing special here at all. It's just a normal activity and I'm observing some live data. Right? There's no coroutine specific stuff in here, so I'm just going to go and close it. But the only important thing is that in onCreate of the activity, I'm calling ViewModel.onCreate. Let's have a look at the view model then, and this is where the interesting stuff is going to happen. So I just have my live data fields and a constructor, so I'll just minimize that because that's not important. The important stuff is going to happen in this onCreate method, which I mentioned is called from the activity. And in here is where I want to go and actually fetch the data from my repository. Now the first concept in coroutines that I want to introduce is a coroutine scope. And the scope just defines how long certain work is valid for. In a typical use case in Android, this will be as long as the activity is alive, right? While the activity is going and showing stuff, you can do work and fetch data and show it, and it's all good and fine. But when the activity dies, you pretty much want to cancel that work so that it's not going to happen anymore, and you won't try to update the activity when it's been destroyed, because that can lead to a lot of nasty crashes. So that is what a scope is. How long does the work stay valid for? Now the simplest one that there is, and you'll probably see everywhere that you look for examples, is global scope. And as the name suggests, this is global, so it lasts for the entire life cycle of the application, so it never gets cancelled. And as such, you should try to avoid using it, rather use more fine-grained scopes, but it's good for demo purposes, so I'll just use it for a bit here. Then on scopes, you call .launch, and this will launch a new coroutine. Surprise, surprise. Now what is happening here is onCreate is called on the main thread, and then I am launching a new coroutine, so it's basically going to branch off of the main thread, and then we have these two things running in parallel now. And just to show what I mean, I'm going to print out after the launch has run, after launch, and then inside the actual launch method, I'm going to print out delayed, and then above there I want to add delay, which is a coroutine specific method, and I'm going to delay it for 500 milliseconds. So what's going to happen is when onCreate is hit, it will immediately print out after launch, and then after half a second it will print out delayed, right? Because these things are happening in parallel, so it does not wait for the launch method to exit. So let's launch the app, and I will open Logcat as well. Okay, here we go. So if I open the coroutine sample, we immediately see after launch and then delayed as expected. So anywho, I'm going to go and remove that now because it's just for demo purposes. And the next concept I want to introduce is a coroutine context. And what this basically means is, where am I running this coroutine on? And in simplest terms, this is either on the main thread or on a background thread, right? Those are the two main contexts there are, but of course you can implement custom ones. But anyway, the global scope will default to running on a background thread, so it is safe in here to go and fetch some data from the repository, and we won't have a network on main thread exception because we're not on the main thread. Right, but now what happens when you fetch this data and you want to update the UI, right? You have to update the UI on a main thread, and unless you do something like live data, but I'm just going to ignore that for now. You need to somehow update the UI from the main thread here, and luckily we have a with context method, which you can switch contexts with while you're inside a coroutine. So I'm going to use this dispatches object and say dispatches.main. So a dispatcher is basically just an implementation of a coroutine context, if that makes sense. So I'm switching to the main context over here, and everything inside this block will be run on the main thread. So here I would be safe to update my live data or to do any other method that updates the view. Right? I'm just going to join that to a string. Of course, live data you can use post value on a background thread, but that's not what I'm trying to illustrate here. This is how we can switch to a main thread. Let's go and run the app and just see that stuff does actually happen as expected. Right, we haven't changed the progress bar behavior, so that will still show up, but with any luck, the text view will now have some text in it, and there we go. Alright, so I said that using this global scope is not great, so let's see how we can do it a bit better. If you're extending from the Android ViewModel class from architecture components, you have a very nice solution available to you. They have an extension property called ViewModelScope that you can use, and I'll just replace it with that. So you can use that scope to launch new coroutines, and if I look at the definition, it says it's a coroutine scope tied to this view model. The scope will be cancelled when the view model is cleared. So that's basically when the activity or fragment it's associated with dies. Then the scope will be cancelled, which is great, because then we can't update the UI once it's gone. But importantly here, it says the scope is bound to dispatchers.main, which means that when you launch a coroutine on the scope, it will default to the main thread. Now you might think this is really strange, because surely I want to be on a background thread to fetch some data. And yes, that is true, but don't worry, I'll show you shortly how it makes sense, and it's actually very powerful. So I'm just going to close that, and an important update that we need to make here is, since we're defaulting to the main thread, I can't call the service now safely like that, so one solution would be to have another with context here, where we switch to, say, the IO context, which is designed for like input-out operations such as writing to file or doing service calls. Now again, this will work because we switch to IO, then we do the service call, we switch to main, we update the UI. But it doesn't look great. There's a lot of nesting going on here, and it's getting tricky to read. So luckily, the launch function takes a default context to use, so I can pass in dispatchers.io inside launch, and we can remove that first with context block. So it will default to the IO dispatcher over here, which is pretty nice. Great, but what if you're not working in a class that can extend the ViewModel class over here, or maybe you're in a different component altogether? Don't worry, you can still use coroutines, of course. You can do this by defining your own scope. Now, a simple use case could be like this, where you just have a field, call it myScope or something, and you just call the coroutine scope builder function like that. And as a parameter, it needs the context that you want it to default to. So I would recommend saying dispatchers.main if you are in a view model. Don't worry, again, you'll see shortly why main is good. Then you could use your scope over here to launch coroutines as much as you like. And then just remember that when applicable, you should cancel the scope. So on destroy or something, you would say myscope.cancel. Right, to stop any work from happening after it's no longer applicable. Again, this will depend on your use case, like where is your scope used and how long does it last. So just use your judgment there, but remember to cancel it where necessary. Anyway, I'm going to get rid of that because I am working in a view model, of course, and I can just replace that over there again. Now, while this does work, and it is a lot better than working with async tasks and having callbacks all over the place, it can actually be improved a bit as well. Now let's see how we can do that. Wouldn't it be nice if the view model didn't have to worry about switching context the whole time to keep it as lean and mean as possible? Well, luckily that is definitely possible. This is something we can do, and it is actually the recommended pattern as well. So what I can do is I can go into the repo. By the way, this is a very simple class. It just uses a retrofit service to get some stuff, and then it returns it. Not too important here. But what I would like to do is have something like this, where where I am switching to the IO dispatcher in the repo, right? And then if I need to just do that and replace sleep with a delay in coroutines. But that's great now because I can remove this. I can remove that default scope, and I will be happy now because the repo itself will be switching to a background thread over here. And I can also get rid of this with context main because, again, this ViewModelScope defaults to the main thread. So now we've already improved it a lot. Now it's literally just 2 lines of fetching the data and then updating the UI. And I should actually also do this. where I set the loading to true, and then afterwards I set it to false. Almost forgot about that. But it's still easy to look at, right? It's all happening sequentially in the launch block. You can see one thing after another what's happening without having to override methods all over the place. And yeah, I like this a lot better. Anyway, we see now that there is red in the repo, which is obviously not good. And it says that suspend function with context should only be called from a coroutine or another suspend function. And this is where the suspend modifier comes in, and we can just add it onto this function and all will be right after that. Since with context must be called within a coroutine or a suspend function, we just make it a suspend function. Pretty easy. And then there's no change required in the view model, but it does have this little gutter icon to say that, alright, cool, I am launching a suspend function over here. Now, as per the official guidelines, when should you mark a function as suspend? Well, only when you have to. So only when that function is calling other suspend functions, then you should add the modifier. Otherwise, you can just leave it off because it doesn't do anything else. Right? If I were to have something like this, where I take out the with context, this is not going to do anything. It's not going to magically switch to another thread for you or offload work to a background thread. It's not going to do anything. Only when you use something like with context will stuff actually happen. So again, only mark it as suspend when you have to. But anyway, this class is now looking pretty good, and so is the view model. So let's launch it for hopefully the last time and see that it works as expected. Here we go. If I open up coroutines, we see progress. Progress is gone, and then we see the result list coming back, which is awesome. And that's how easy it is to actually implement coroutines, right? You just have a launch function, and then you switch to a background thread to do your work, and you're all good. And that's pretty much all I've wanted to touch on for the basics. But before finishing off, I wanted to just speak about unit testing as well, because it is very important. And we have all these wonderful things like with context and dispatches and suspend functions, but how do we actually test all of it? Unfortunately, it's actually made really easy because they have a lot of test helpers that we can use. Now, one of the most important patterns that they recommend for testing is to inject your dispatcher that you use. Right? So take it in as a dependency into the constructor and then use it there, instead of using it like I have here. So what we can do is we can just make a new constructor argument, that is the dispatcher, and make it a coroutine dispatcher type. And then we can go and use it in the with context over here. And then of course in the constructor we'll need to pass in dispatchers.io. This constructor is called from the production code, and then this other one is of course for testing purposes. Okay, so let's look at the test itself actually. And when I'm calling the constructor over here, I need to actually pass in a dispatcher, right? Because we added that argument. And what you can do is you can pass dispatchers.unconfined. This is just a special kind of dispatcher that's not limited to any specific thread, but it will just run on the thread that this is called from. So that will be the main thread in this case. So you can use that in your unit tests. There are other more complicated ones like test coroutine dispatcher, but those are for more complicated use cases, so I'm not going to cover it now. Now if I go to the actual test method, we have some red over here because fetch data is now a suspend function, of course, because we added that modifier over here. And of course you can only call suspend functions from other suspend functions. Luckily there's a test helper called run blocking test that we can wrap the method body in. And what this method does is it will launch a new coroutine, but it will block the main thread until the coroutine finishes. Right? And then we are safe to call suspend functions in there, of course. And this is pretty great, and the rest of the test would be pretty much as normal, where you can mock out various elements with Mockito, and then you can do your assertions and other things like that. Let's just run it to make sure that it does actually work. Okay, so it actually failed, and that's because I forgot about this delay that we put in the method here to emulate a long service call. And it normally doesn't play too well with delays. That's where you'll need that test coroutine dispatcher that I mentioned earlier, if you do actually need to put delays in your normal code, which is a bit strange. But I'm just going to take it out here because I don't really need it, and rerun the test, and we should have a passing test now. Yes, there we go. All green and all happy. So the important things from this one was using unconfined dispatcher and wrapping it in run blocking test when you need to call a suspend function. Alright, all happy there, so let's take a look at the view models test now. And this also has some interesting stuff in it, but for different reasons. The main trick here is that ViewModelScope, right, it defaults to the main dispatcher as we saw earlier, but in tests, the main dispatcher doesn't exist because we're not actually running an app. So there is some test setup that you have to do, but luckily it's fairly easy because there are test helpers. So the first thing that's important in this unit test is, again, in my setup method, I am saying dispatchers.setMain over here to our good old unconfined friend over here. And this will just use the unconfined dispatcher when ViewModelScope is used. And then over here we again need run blocking because the repos method is a suspend function. Run blocking and run blocking test will do just fine in this case, so you can use either one. And then we just instantiate the view model like normal. And in the teardown method of the test, we can reset the dispatcher as well after we set to unconfined above. And in the tests themselves, there's nothing too crazy here. I've just wrapped them in run blocking test again. I don't think this one was actually necessary though, the second one. Yeah, that one will be fine, but since I'm verifying again that the repo method is called, which is a suspend function, this has to be in a run blocking test method, but the other one can be like that and it will be fine. So let's run this test and see that it passes as well. So there we go, both tests pass. The first one verifies that the repo is actually called, and the second one verifies that the live data is being updated correctly. Pretty straightforward. And you can pretty much write normal tests once you've got the hang of using these run blocking test stuff. And that's all I wanted to show off for coroutine basics on Android. Hope that it was actually valuable and that you learned something. Please do let me know, I'm always keen for feedback. But thanks for watching, hope you enjoyed, and cheers for now.